substitution is a way to integrate where it may just not be a plain rule. So what do I mean by that? Let's look at something like the integral of secant squared of x dx. That's actually just a rule. The integral would then be tangent of x. Because tangent's derivative is secant squared. But then I could have something like this. This has now become a product, and for integration, just like derivatives, we can't just simply do integration or do a derivative of a product without a rule. For derivatives, we learn the product rule. For integration, we don't have any rule except for substitution. So what you're going to be looking for is when you assign something to be u, you want du, its derivative, to be another part of the function. So this underline right here should end up being the other part of the function. So using the example we had here, we know that tangent's derivative is secant squared. And so contrary to how we did the problem in 1, our u is going to be tangent of x because du is secant squared of x, and we're going to multiply it by dx. Where does that really come from? It used to be du over dx, and we multiply both sides by dx. Given that we have that, now everything you see in yellow is going to be substituted for everything over here, and we're going to substitute in du in the place of what's in those boxes. And so we end up with the integral of u, which is tangent of x, and instead of the yellow secant squared x dx, we're going to substitute in d of u. So now we're going to integrate. Well, that would mean that we have u squared divided by 2 plus c, which would end up being, substitute back in u, tangent squared of x over 2 plus c, and that would be our integral. So I have a few more examples of u substitution. If you're still having trouble with this, it's really a method of being able to see whose derivative shows up in the function also. So now we're looking at the integral of e to the tangent of x over cosine squared of x dx. So let's look at some things. I know that this divided by is going to be an issue because I can't do a quotient rule for integrals. I also don't really have a chain rule for integrals. And so right now my issue is that I have a tangent of x and I also have a cosine squared of x. Well, in my mind I'm thinking, well, tangent's derivative is secant squared of x, which doesn't show up. Cosine's derivative is negative sine of x, which doesn't show up. Cosine squared's derivative is 2 cosine of x negative sine of x, which definitely doesn't show up. But the reason why I gave this problem is you actually can rewrite the problem to be the integral, there we go, of e to the tangent of x. And instead of putting divided by cosine squared, well, I can put multiplied by secant squared of x. So similar to the problem we had before, my u will end up being tangent of x, because then du is secant squared of x dx. This in white will replace all of this. The fact that u is tangent of x takes the place of my chain rule. So we got rid of the product rule and we get rid of the chain rule by turning this into the integral of e to the tangent of x, which is u. Its integral would be e to the u plus c. And so the answer to the problem would be e to the tangent of x plus c. All right, let's try another one. ln of 3x squared all over 2x. And let's hope that I did not make a mistake with this. I feel like this one may not work out. So it does look like this one will work out. I had to take a second to think about that. All right, so let's talk about issues. Issues are, we have a chain rule, and the other issue, we have a quotient rule. So if I made u to be 2x, its derivative is 2, not really helpful because it doesn't get rid of the chain rule. If I made u 3x squared, du would be 6x. The problem is that the 2x that we have is actually a denominator. And so we actually would not be able to substitute out the x that's at the bottom. The 2 doesn't really matter because that's a coefficient and we can move that anyway. So we're back to the problem that neither of these are going to work. Then we can look at u to be ln of 3x squared. So let's look at that. Du would be 1 over the inside multiplied by the derivative of the inside. Well, that simplifies out. Let's see. We get 6 on top. We get x on top. We get 3x squared on bottom. And we end up with 2 over x. Well, that might be helpful. Du is equal to 2 over x dx. So it looks like this 2 right here is actually in the way. So what do I mean by in the way? We don't actually have a 2 in our numerator. So what I'm going to do is move over here, and I'm going to say, let me get rid of that 2. I'm going to move it to the other side. And I have 1 over x dx. So let's highlight. I know this is the same as this piece and the same as this piece. So what do we end up with? We end up with the integral of u times du divided by 2. So we still have the divided by 2, which comes from this 2. And then we actually have this 2 I'm going to put out front as a 1/2 instead. So if I want to make things easier for myself, I can bring both 2's to the outside, factor it out. I just get left with u du. So its integral would be 1/4 u squared divided by 2 plus c, and I end up with 1/8 u squared plus c. So the actual integral would be 1/8 ln squared of 3x squared plus c. And I think out of all of them, this one's probably the hardest one to be able to tell what should you make your u. So I purposely made a few mistakes here. I purposely showed you why you wouldn't use 2x, why you wouldn't use 3x squared, and why we would use u to be ln of 3x squared. Okay, and one note, which I'll make sure to put in, I am going to actually put, let's see, I'm just kidding, apparently. Example 3, moving on. So 4x squared cosine of x cubed. So when I'm looking at this, hopefully you kind of notice the quotient rule, the chain rule and the product rule is what we need to get rid of. But if you do think about it, x cubed, its derivative will be some derivation of x squared. And in this case, it's 3x squared dx. The x squared I have, the dx I have, the problem is I don't have this 3. So the 3 gets moved to the other side. So all of this is substituted out, and I'm going to place in its place du divided by 3. So I'm actually going to rewrite the problem to say the integral of 4 cosine of u, the du is here, and the divided by 3. So if you want, you can bring out the 4/3 and make it the integral of cosine of u du. And so what I end up with is 4/3 sine of u plus c. Therefore, the answer to this problem would be 4/3 sine of u, which is x cubed, plus c. So hopefully that was another good example.